Hello students, കഴിഞ്ഞ ക്ലാസ്സിൽ നമ്മൾ curvature define ചെയ്തു. So recall, if gamma is a unit speed curve, then curvature kappa was defined to be norm of gamma double dot. So this is at every point we can define curvature, and if gamma is not unit speed but regular, if gamma is not unit speed but a regular curve, means velocity is never zero, then curvature kappa equal to, we derived a formula, norm of gamma double dot cross product with gamma dot divided by norm of gamma dot cube. This is provided gamma is a curve in R3 or in R2. Here this works everywhere in any Rn. Why is this difference? This is because the cross product that is defined basically in R3, and you can define cross product even in R2 also. The cross product of two vectors is a vector perpendicular to both those vectors. So if you have two plane vectors, then the cross product of those two vectors can be considered as a vector perpendicular to that plane. So it can be, or it may be treated as a scalar, because there is only one component for that vector. The other two components will be zero. So this formula works in R3 or even in R2, but not in R4 or R5. We will see an example. Find the curvature of the helix. Hope you know what is helix. This parameter is as gamma of theta equal to a cos theta, a sin theta, d theta. So helix means it's a spring kind of object. It winds round a cylinder like this. So this is helix. So this is winding around this cylinder. I don't have to show. I should show only the spring portion, or that particle moving in space. So I will remove those two straight lines which are part of that cylinder. Yes, this is my helix. So is this a unit speed curve? So what is gamma dot? Gamma dot is, so answer, gamma dot is minus a sin theta, a cos theta, b. So norm of gamma dot is equal to square root of a square plus b square. Need not be equal to 1. It depends on a and b. Therefore, this is not a unit speed curve. So you cannot use this formula or this definition to obtain the curvature. You can't use. Therefore, we will try to use this second formula. This one. This you can't use in this situation. So gamma double dot we will find out. Gamma double dot is equal to minus a cos theta minus a sin theta and 0. Okay. Now what we are supposed to do? Norm of gamma. First let us evaluate gamma double dot cross gamma dot. So this is equal to determinant I j k minus a sin okay, here gamma double dot. So it is minus a cos theta, then minus a sin theta, k is 0, k component is 0, then for gamma dot it is minus a sin theta, a cos theta and b. So when you evaluate this determinant, what you are going to get is let me see. Where is that? Yes. It is minus ab sin theta vector I equal to minus ab sin theta vector I plus ab cos theta vector j minus a square k. Okay. We will compute the norm of this vector. Norm of gamma double dot cross gamma dot equal to, so how much it would be? A square b square sin square theta plus a square b square cos square theta plus a to the power 4. So a square b square plus a to the power 4 a square b square plus a to the power 4 square root of that. So it is a square we can take out from here and here. Square root of a square into, that means mod a into square root of a square plus b square. Alright. Now we will compute norm of gamma dot, cube of that. So what is norm of gamma dot? Norm of gamma dot is square root of a square sin square theta plus a square cos square theta plus b square. So square root of a square plus b square. Square root of a square plus b square. Square root of a square plus b square. So we can calculate kappa now. The formula is norm of gamma double dot cross gamma dot divided by norm of gamma dot cube, which is equal to mod a into square root of a square plus b square divided by cube of this. That means a square plus b square whole to the power 3 by 2. Right? So here in the numerator you have a square plus b square whole to the power 1 by 2. Denominator you have a square plus b square whole to the power 3 by 2. So cancel. So you get mod a divided by a square plus b square. This is the curvature. At every point, this is the curvature. Curvature is the same at all points because it is independent of s or t or theta here, the parameter. Here the parameter is theta. So let us examine what happens in the limiting cases. So what is meant by limiting cases? The limiting case. So what is meant by limiting case? Suppose b equal to 0. B equal to 0 means what happens? Here you have gamma of theta equal to a cos theta, a sin theta, comma 0. That means it is a circle in the xy plane. It's a circle in the xy plane. This helix reduces to a circle. So b measures the height in which the particle goes up or down, because that is the z coordinate. Z coordinates determine the height. So if the height is equal to 0, then the curve is a circle of radius a in the xy plane. So what is the curvature of the circle? It is 1 by a. 1 by a is the curvature of the circle of radius a. Now let us look at here. According to the formula, when b equal to 0, curvature becomes kappa is equal to mod a by a square. It is mod a by mod a square. So it is 1 by mod a. So according to this formula also, the curvature is 1 by reciprocal of the radius of that circle. Now the next case is suppose a equal to 0. Suppose a equal to 0. Then what happens to the helix? When a equal to 0, it is gamma of theta equal to 0, 0, b theta. So it is just the z axis. It is just the z axis. As theta it is, b theta increases or decreases. So it is just the z axis. And the curvature of that z axis, which is a straight line, must be equal to 0. And according to the formula for curvature we obtained here, when a equal to 0, kappa is again equal to 0. So this formula agrees with the limiting cases. Thank you.